Okay, so this is 41 out of 8.3, where they give us a region. So they've got the first quadrant, right? And then they said, okay, from 1 in the y to 1 in the x, there's a circular arc. And then there's a cutoff at 2. And then we want an inequality to describe everything in here.
That's area above the curve?
In polar, yeah. So I want to be able to describe the area above the circle in the first quadrant, left of the line 2. X is 2. All right, so let me start with in the first quadrant. Cool. So just to get things in the first quadrant, what needs to be true about the r's and the thetas?
You.
Okay. Let's go with r needs to be positive. That's kind of a standing assumption that I'm usually making, but let's write it down. I think that's a good idea.
Theta needs to be 0 and pi over 2.
Good, perfect. So 0 has to be smaller than theta, has to be smaller than pi over 2. You guys good with that? So that'll keep me in the first quadrant. How about, oops, not Q. How about outside of the circle? How do I get outside of that little circle?
Or you can do sine.
R is bigger than 1.
Good. R has to be bigger than 1.
Less than 2.
Okay, see that?
Well, less than 2 at 0 theta.
Yeah, and then the other thing's going to get inconvenient. Cool? So I'm going to go with this for right now. That's just to keep me outside the circle. So I've got in the first quadrant, outside the circle. And then let me stay inside that weird boundary at 2. So to do that, it depends on the, what did you say, Alvin? That when theta is 0,
R has to be less than or equal to 2.
yeah, does that change when theta gets bigger? Yeah, seems like, right? If I just said this condition, like if I just said R has to be smaller than 2, right?
It would make another circle.
Yeah, it would make another circle like this. Crap. So I think the trick that you probably need is just draw something in here. Call this angle theta, right? What do you know then about this black triangle that I just randoed in here? Good. The opposite side, the opposite angle here, right? The angle down in the corner is right. Why?
Because you made it that way.
Yeah, because
that's
the x-axis and x equals something are perpendicular, right?
Well, if it's, since it's radius of 1, you can assume it's a unit circle, and as soon as you cut it in half,
You could do the arc
45.
angle.
Oh, sorry. Don't get attached to the idea that I drew this picture. This would also have been perfectly valid.
I know, but could you? Like,
I don't think you want to. I think you want to do this for a general angle.
okay.
So I'm just drawing some angle theta, right? That really could look pretty much like whatever. Really what I'm trying to do is I'm trying to come up with an equation for this vertical line so I can say that the r's have to be small.
I feel like tangent would be really helpful.
Maybe, yeah. So this side here has to be how long?
2.
Yeah, that side there's 2 long, right? Boom, boom, done. Okay. Now, what's the radius? What's the radius's relationship with 2? What do I know?
That's the minimum.
You guys see that? Like if r is bigger than this, then it's outside. You guys see that? So let me just assume r is equal to this. Let me assume that we're actually hitting the edge. So what do I know that relates things like 2 and things like r with things like theta and right triangles?
Like S.
Yeah, cosine specifically, right? So here I know that cosine of theta is what?
2 over R.
2 over r. And that's to be exactly the black triangle I drew, right? You guys with me on that? Okay, so that means that r is 2 over cosine of theta, right? You guys with me on that? And that would be r's out here, right? That would be this. And I want r's to be,
More than less than
yeah, I want r's to be smaller than that. So I'm going to,
smaller or equal.
you guys see this? So now I have to add all these conditions together. So this condition here is for inside x is 2, whatever that means. Left of x is 2. So let me add all my conditions together. So what are my conditions on theta?
Greater than or equal to 0.
Yeah, they haven't changed at all. The only conditions on theta are that first set to keep it in the first quadrant. So theta has to be smaller. Theta has to be between 0 and 2 pi. Cool? That's just keeping me in the first quadrant. Now, what about my radii?
They still have to be bigger than 1.
Good. The radii have to be bigger than 1. And what else?
Smaller than 2 cosine.
Good. They also have to be smaller than 2 over cosine theta. You guys see that? So that's what you got. Check, done. It was this thing, right?
Yeah, that was the thing I was didn't want to deal with it.
Yeah, that thing's super hard, right? Because it depends on the angle theta. So my advice is peg one, right? Like just draw a rando picture with some theta. Don't assume anything about theta. Solve for it, and then maybe that'll help. In this case, it happened to be helpful, but sometimes that turns into a
Would it be-
disaster.
Oh, we would probably use sine, and maybe if it was like cut off at the top instead of.
Yep, so if we were cut off at the top, we would know about, yeah, so if we were cut off at the top,
We would know the sine.
we'd peg a random angle theta, right? And then, well, this is actually really inconvenient. You guys see why?
Oh, because we don't have the actual.
Yeah, because the triangle I want is that one, right? So this angle here is pi over 2 minus theta, right? Like it's whatever's left.
Why'd you have, how come that one's pi over 2? How can you just make that angle? Because it's going through the, oh,
Well,
just
so you could
start-
do this. You could say this angle's theta.
Yeah.
That's actually a good idea. I was going to use the sum of angles identity because that's what we're supposed to talk about today, but you guys can use whatever. So if you notice that this one's theta because they're opposite interior angles, awesome. And then you can use whatever on
That's the
this.
same thing.
It'll be a sign on that one.
So for the, for the original problem on the second one, yeah, though that whole line right there of 1, what's that represent? Does that represent the curve of the circle?
Yeah, so this is saying the radii, right?
Of the circle, right? Inside.
No, of the line.
So the radius to get to one of the points in this thing. So I'm talking about like here's a point in this thing.
Okay.
And the radius has to be bigger than 1, meaning I'm not allowed to be inside the circle.
Right.
And it has to be smaller than that other thing, which means that I haven't gone over here.
Okay.
So that for a given angle, the radius has to be someplace bigger than 1 to keep it outside that, and smaller than the other thing to keep it inside the line.
Okay.
You guys cool with it? You want an XY analogy? That helps.
That's okay. I can see it.